When I grab the camera, apparently I pressed the off button on the video. So take 4 on this video because I spoke out the rest of the video because I thought I was still recording. So yay my day. So charging by induction. So I'm going to write some basics here and then we'll kind of go through the process a little bit more specifically. So start with one charged, one neutral. The charged object never touches the neutral object. Not that something else doesn't, but the charged object doesn't. Remember that the end result here is that the neutral object ends up with the opposite flavor of what charges it. Okay? So that's the basics, but now let's go through the specifics of how that happens. So here we go. Let's say I have a negatively charged object and my neutral sphere. So technically that neutral sphere will polarize in the presence of this negatively charged object. But I'm going to say this very specifically right now. It is not relevant that polarization is happening. That happens just because of time sequence, but the polarization step in this is not relevant in this process. All right, cool. Cool. So now I'm going to ground this object in order to have a pathway for electrons to move on. It doesn't actually matter where I ground it. I could ground it on this side or this side. It doesn't matter, right? I'm just going to ground it here because the picture is neater to draw. So what ends up happening there? Well, excess electrons on this feel repelled by this and therefore want to go to a place where they're no longer feeling repulsion or to minimize the repulsion. In this case, that is off the object. Now, what I want to do here is if I remove the charged object, the electrons are going to rush right back onto this sphere. So what I want to do is remove the ground. And then what am I left with? I'm left with an object that is positively charged because electrons have left it. Okay, so what does that look like if I had used, say, the glass rod? So here's the glass rod, and here is my neutral sphere, and now I ground it. Great. Here, electrons will be drawn up from the ground onto it. Once again, I want to remove the ground, not remove the object, because I've removed the object, the electrons are just going to go back to the ground. So remove the ground, and then I am left with an object that is negatively charged, okay? And so that's what's going on in charging by induction. Now, just to show you this slightly different way, let's say if I had 2 of these metal spheres here, and they were touching like that, and I brought the negative object here, this system holistically would polarize, and I'd have electrons moving from the first sphere to the second sphere. And so then if I separated the 2 spheres, I would end up with this one being negative, and yes, this one would end up being positive, but we say that this is the one that was charged by induction, the one that was closest to. Essentially, once again, I just need to have a source or somewhere to throw the excess electrons or draw electrons off of in order to do a charging by induction process, okay? And charging by induction is distinct from polarization because the net charge of this object changes, whereas in polarization, it does not. So there we go, our 3 charging processes: charging by friction, charging by conduction, charging by induction. And there we go.